ability of the plant to uptake the water. Therefore, it will affect the plant growth and also the yield. And the second type of salt-affected soil is sodic soil that contains the excess amount of absorbed sodium ions, and because of that, it will change the soil structure, and then it also restrict the aeration and also water movement, because of that it affects the plant growing on that soil. And the third one is the combine between saline and sodic soil. So most of the problem with the topsoil and also the subsoil are the saline. The saline soil is it with the more than 85% of salt-affected topsoil are saline, and that's 62% in the subsoil. So this figure shows the distribution of the salt-affected soil over the world. So as we can see that this problem happens all over the world. It's not just any continent or subcontinent, it's all over the world. So is it the worldwide problem? So how we see the salt-affected soil affect the plant when we grow it that's the soil. So with the saline soil, they use it electrical conductivity at the measurement. So when the electrical conductivity is greater than is between the 2 to 4 decibels per meter, it will start to affect the yield of the crop growing on that, especially some the sensitive crop. So with the movement of like the increase of the saline, that means sodium chloride mainly in the soil, the stronger the electrical conductivity, like the yield of the crops will be decreased more. So rice is an important crop that feeds more than half of the world population. And I believe that you here also is rice, right? So I'm original from Vietnam, when we eat rice like 3 meals per day. Yes, and rice is mainly grows in Asia, but it currently it grows more than 100 in more than 100 countries in over the world. And unfortunately, rice is very sensitive to salinity stress.
And using silver for synthesizing the nanoparticle because it is one of the basic element. It is rare, but it is naturally occurring element, and it has 4 oxidation states, 0, plus, 2 monopositive, dipositive and tripositive states are present. So we have chosen this one, and silver is also non-toxic in nature. Several examples of inorganic nanoparticles, carbon-based nanoparticles and hybrid nanoparticles I have shown over here. As I already mentioned, that silver nanoparticles show unique properties in comparison to their bulk counterparts, and they show broad spectrum antimicrobial activity. They are very much in the field of clinical applications, biomedical applications. Some of the threats include their cytotoxicity. So in our present study, we will discuss the synthesis methods. Various synthesis methods are there, the physical, chemical, biological and some other, and we will discuss the one we have chosen for our study. We will identify the synthesized silver nanoparticles using various characterization techniques, and we will find its antifilarial and antimicrobial relevance. So this is the evolution of silver nanoparticles, the key developments. Ancient times, the 20th century, it was the discovery of nanoscale properties. In 1990s, it was the development of synthesis methods. So the synthesis methods overview, mainly it can be categorized under 2 parts, the top-down approach and the bottom-up process. Here we can show the pictorial description. In case of the top-down process, we start with the bulk moiety and then we get the silver nanoparticle. And in case of the bottom-up approach, the molecules and atoms, they undergo nucleation or aggregation and then we get the nanoparticle. So all of the processes we will be mentioning comes under these two processes, the physical method, chemical method and the biological method. So we will start first by discussing the green synthesis. So for this we have taken some plant material. We will make the extract, and to this extract solution silver nanoparticle will be added, AgNO3 solution, where silver is present as the monopositive ion, and we will get the biosynthesized silver nanoparticle. The pictorial description shown here. These are the various chemical methods of synthesis of nanoparticles. Some of them include sonochemical method, chemical reduction, co-precipitation. This is the chemical reduction process. So in the first case, we have taken AgNO3 solution where silver is present as the monopositive ion, and then we will add some reducing agent to it like NaBH4, sodium borohydride, or we can also use trisodium citrate for that, and the monopositive
benzoic acid. Benzoic acid is used as a food preservative, food additive, so we eat these compounds when we in our everyday life. So in excessive amounts is still a danger, but in appropriate way we can use it as a food preservatives. And when we add to the benzoic acid another hydroxyl group, we achieve a salicylic acid, which is a plant hormone. So also it is safe for environment, it is safe for human health. So as you can see, chemicals are not bad itself. We can design the synthesis, we can design the chemical structure, design the properties, so we can design also application of these compounds. And this is an example of salicylic acid and its sodium salt, sodium salicylate, and the property which we can design is water solubility. In 25 Celsius degrees, salicylic acid can dissolve in 2.5 grams per liter, but if we want to increase the water solubility, we should change the chemical structure from carboxylic group to its sodium salt. Another example is acidity. So the salicylic acid possess their acidity 3.5 pH, but if you want to decrease pH, we can add to the structure chloride atom. If you want to increase create compound with neutral acidic base properties, we can, for example, change the structure into ionic structure combined with compounds based on the ammonium salts. And also we can create simple potassium salt. Also we can design the application. The compound here, which is benzoic sodium salt, is a food preservative. When we add a ammonium group, it's an antibiotic. We can also create or synthesize biostimulant compound. So some of the compound may be designable because of their chemical structure, and we can change the structure into ionic structure. Here you have example of sodium chloride. Everyone knows sodium chloride because we use it in our cuisine as salt. It is composed of anion and cation. Sodium cation, chloride anion. And in room temperature, the structure is crystalline. But if we heat it to 800 Celsius degrees, the ions can move independently. So they are like a liquid state. Of course, in case of other organic salts, we can synthesize compounds that can melt even if 40 Celsius degrees or even in room temperature that are in liquid form. So we can synthesize compound with cation and anion, then change the structure of cation, change the structure of anion. So we can make a platform to create the compounds with targeted properties, because some of the properties
with no photochemical quenching, okay, but in this context we need to help the vine to overcome this problem. The Australian Grape and Wine Authority said that prolonged period temperatures greater than 35 degrees 40 degrees may affect the primary metabolism, so photosynthesis, conductions, transpiration, and so on, and the secondary metabolism, so the phenylpropanoid accumulation, so polyphenol, anthocyanins, the total one, and the extractable one, the second one, in a berry. And we sent some pictures. This is Sangiovese in Tuscany. So bunch burns, brown and necrotic spot on a canopy, so a lot of problem for the growing maker. So this is unbalanced maturity. There are two possibilities, so two paths about this problem. So the first one is the total arrest of ripening, so no maturation, no, the sucrose doesn't upload in a berry, and the phloem stopped their flow. And there is some pictures, so this is our experiment. For example, this is an introduction, so treated grape with zeolite and irrigated one, just irrigation, only zeolite application, and no treated grapes, so no zeolite, no irrigation. So there is pictures that can show really the situation. And the other could be, we could have no arrest of ripening, but a mismatch in the primary and the secondary metabolism, so an excess of sugar. And this is excess of sugar could create a problem during fermentation with a high level of alcohol, and the problem in the enological part. In this context, we have to talk about sustainability. So the sustainability in 1987 was defined by the United Nations Brundtland Commission as the meeting the needs of the present without compromising the ability of the future generation to meet their own needs. And this is approach, the conservative approach, the sustainable approach in agriculture in general, but in vineyard is a great important. We have to we have to think about to preservation of the ecosystem, to give quality to in vineyard, but we have to have this sustainable approach in vineyard. So what is zeolite? Zeolite is the aim of this project. Zeolite is, first of all, is identified as not toxic by the International Agency Research of Cancer. They were discovered by a mineralogist, Alex Frendis Cronstedt, in 1756. They are minerals, or they are tecto-aluminum silicated. You can imagine the zeolite as a framework with pure and void, with the geometric crystalline structures. They have a negative charge. They have their word means boiling stones, due to their ability to gradually release water when heated. And they are combined by different silicon and aluminum.
The process, we selected habitat types, how to how to change these studies. First photos. On the first photo, you can show pioneer successional stage of plant forest restoration. Why pioneer? Because it is a subalpine secondary meadow where first appeared seedlings of birch. You can show seedlings of birch, but not just birch seedling. There are different kind of tree species, wood species, and shrub species, and others. This is here is combination species combination, which are combination of birch forest. This photo, on this photo, you can see a logical successional stage. It is a secondary stage of forest restoration because here is more high trees, but this is not fully ecosystem of birch. It is a temporary forest. Yes, and the third one is climax birch forest, primary forest, which is protected area by charge, and so there is not anthropogenic influence. It is a very good safe forest. First habitat type is birch forest as well, which is you can see how destroyed some area by anthropogenic influence. On this area, people live very near, so they used this forest for firewood, and it is very bad quality. And last one is our study habitat types. It is tree line ecoton. It is up to timberline, very high, more than 2,000 meters high elevation, and you can see small trees of betula with associated with rhododendron shrubland, so we studied different methods. Our study sites, there we described and studied environmental conditions. You can see some data: vegetation cover, sky exposure, soil litter cover percentage, trees height, shrubs height, and others. And so we have had very many data, which we process different programs of statistics. This is carried out in PCORD program PCORD, where we combined environmental data and species cover percentage for all habitat type. We determined for each species cover percentage. And
so I will just present all the preliminary results that I have with every one of you here. So generally, to start off with the introduction here, I will talk a bit about rice industries in Malaysia. If you look at the graph here, you will generally see that the rice production in Malaysia is actually very, very fluctuating. Okay, so if you look at the year 2020 and 2021, there is a drop in terms of the production of rice, and generally 30% of our rice is still dependent on importing the rice from countries like Indonesia, like Thailand, and also from India. So if you look at in terms of the national level, when we talk about all this rice, when we talk about food security, definitely we'll have to look at one of the important aspects here on self-sufficiency ratio, SSR. So in Malaysia, what is the sad thing here is that in terms of rice, SSR is only about 63%.
meaning that we are only able, whatever that we produce is only able to cater for about 33% of our population. Another roughly about 37% of our population will have to rely on import of rice from outside of Malaysia. So this is the SSR in 2020. But if you look at the next report that coming in 2024, actually the ministry has realized that the SSR has actually dropped from 63% now to 56.2% only. So it's a further drop here. So if this continue on without any further actions, Malaysia will be facing serious food insecurity issues because rice is our staple food. All of us rely on rice every 3 meals. Okay. So in terms of why we are facing these issues here, generally there are a few challenges that we are actually facing here. Of course, the one that we are talking a lot of the contributing factors is generally because of global climate change that cause a lot of flooding issues, a lot of drought issues in context of Malaysia, as well as because of all this global change. And then in terms of the production of new rice variety, we are not able to produce enough, fast enough new rice variety to support the population here. And in terms of pests and diseases and also long planting period, there are also some of the contributing factors, but it's not that drastic at this moment of time. So because of this, then you will look at this specifically in terms of global climate change in Malaysia. In the context of Malaysia here again, you will find that the statistic shows that about 9 million hectares of our paddy field is actually damaged due to drought between 2017 to 2021. And with all these damaging effects on paddy field, it actually caused a loss of about 21.6 million. It's more or less like about 5 million of USD. So in terms of this, that's why our Ministry of Agriculture and Food Industries, they actually formulate the National Agro-Food Policy 2.0 since 2021 to 2030 in order to overcome the problem of food insecurity issues. So one of the part that we are actually looking here is actually to look at generate a new rice variety. So I think this morning Dr. Ling Hong also mentioned about this. One of the ways for us to generate a new rice variety is through some mutation breeding techniques. So this is the part that we are actually looking at. So we are looking at in terms of using mutation breeding techniques to produce new rice variety. And the good things about these mutation breeding techniques here is generally in terms of the Malaysia context here, okay, the mutagenesis is exempted from the Biosafety 82007. So it's not considered as part of the GMO in Malaysia. So that's why we are...
Among them, we focused on reactive oxygen species, ROS. ROS are generated at the wound site and can propagate to distant parts of the plant. To test whether ROS are involved in callus formation, we applied DPI, a well-known NADPH oxidase inhibitor, to suppress ROS production during callus formation in Arabidopsis leaf plant. After the DPI treatment, callus formation was obviously suppressed and the expression of callus marker gene also decreased. Next, we analyzed whether DPI actually reduced ROS levels. So we performed MBT and depth staining to detect superoxide and hydrogen peroxide respectively. In the control, both ROS accumulated strongly near the wound site, especially the vesicular tissue and border of callus formation. The vesicular tissue is the site of callus formation. Yes. However, after DPI treatment, ROS accumulation was notably reduced, especially at the vesicular tissue. These results indicate that wounding-induced ROS production via NADPH oxidases and that this ROS production is required for callus formation in leaf plant. So we conclude that ROS act as the wound-induced signals that initiate callus formation. Then, how do plants recognize wounding to produce ROS? To answer these questions, we hypothesize that cuticle removal serves as a sign of wounding, because cuticle is the outermost surface of aerial organ and is physically disrupted by wounding. So we conducted toluidine blue O staining, which detects cuticle permeability. As expected, toluidine blue O staining showed strong signal around the wound site, indicating increased cuticle permeability. And then to test whether cuticle defect really induced ROS, we treated leaves with a mild surfactant silhouette before callus induction. Interestingly, silhouette chemically disrupt the cuticle integrity. Interestingly, silhouette-treated leaf explant showed cuticle formation and ROS accumulation across the whole leaf surface, even in non-wounded regions. Similarly, the cuticle defective mutant LEX2 showed wide.
Me chamo Thaís Braga, sou engenheira ambiental e sou pesquisadora, professora da Universidade Federal Rural da Amazônia, fica em Belém do Pará, no Brasil, onde vai ocorrer a COP30, né, esse ano. E esse é um projeto de pesquisa do nosso grupo de pesquisa, onde eu lidero, um projeto chamado Selo Amazônia Mulher. O projeto consiste em certificar produtos de genética, melhoramento genético, agricultura, manejo florestal da Amazônia para o mundo. Então, o projeto ele consiste da gente oferecer um selo, que é esse selo aqui, o selo Amazônia Mulher, para todas as produtoras mulheres do Brasil. Então, agricultura familiar, indígena, quilombola, tradicional, eles recebem o selo para que os produtos deles possam ser escoados para fora do Brasil com segurança, rastreabilidade e qualidade técnica. Aqui é o nosso grupo, né, as pessoas que atuam no projeto. Nós viemos aqui, a Universidade Federal Rural da Amazônia, né, é uma universidade que atua tanto na Amazônia legal brasileira quanto fora. A nossa área de atuação é o Brasil, né? Aqui é um vídeo, deixa eu ver se passa o vídeo. Não, bem que era um vídeo. Enfim, e aqui são os nossos produtos que recebem o selo. Todos os produtos que advêm da agricultura familiar, da agricultura tradicional, do manejo florestal, do melhoramento genético da Amazônia, da floresta brasileira, a gente consegue certificar esses produtos. E os produtos conseguem sair do Brasil com essa qualidade técnica, digamos assim, né? Aqui é um projeto que a instituição executora é a universidade. A gente tem o fomento do governo brasileiro, governo do Pará, da Amazônia, e a Fundação de Apoio e Amparo à Pesquisa, que é a FAPESPA, que é a Fundação de Pesquisa do Estado do Pará. Então aqui a gente tem as meninas que fazem parte do projeto. Quem executa o projeto é o grupo de pesquisa liderado por mim e por outras professoras de outras instituições técnicas, né? Aqui a gente trabalha tanto com a questão da visibilidade quanto da conectividade dessas mulheres com outras regiões e outros países, para que elas possam escoar os seus produtos e que os produtos da Amazônia possam chegar para outros países. O projeto beneficia mulheres da Amazônia em povos e comunidades tradicionais, indígenas, ribeirinhos, quilombolas, brasileiros, mulheres que atuam gerando renda, gerando emprego e consolidando a bioeconomia da Amazônia. Além disso, a gente tem um site onde todas essas mulheres são alocadas e todos os produtos certificados, eles recebem essa chancela da academia técnico-científica, reconhecendo e valorizando a qualidade técnica e financeira, econômica desses produtos. Aqui são os eventos, a gente faz todo o processo de certificação, análise, auditoria, verificação, validação e rastreabilidade desses produtos para que eles consigam.
The main issue is the big river that spans through the Benue Valley, which is the North Central region. That has, if you look at the outlook of the North Central region, and the length of the river that spans it, the length is 1,483 kilometers. So the banks of it becomes the most fertile area for agri production in Nigeria. And then the population there is over 20 million, and annually the total income from that is over 45 billion US dollars. But the main problem we have is that the fertile line also have proven oil reserve and gas, and it will have other solid minerals. And this is the beginning of the problems of the farmers who are mainly agricultural producing areas. The map here represents the North Central. You see where North Central is written, that is the area. And then you see the general problem, North Central region's political and economic implications. First, there is kind of political agitations in my country of who will control the valley, the Benue Valley, which represents the North Central. And the agitation has been, this area, the people are farmers and weak. At the moment oil reserve was discovered, there's that a stronger decision from the powerful areas and communities in Nigeria to have control of this. And the specific issue I've highlighted two dimensions, the general dimension, which is the control of the area. The specific ones now is that the area now is suffering extreme neglect in agricultural investment and even the federal government support. And why is this so? Those people want to control the oil that is beneath the soil. And they don't care of the land which the farmers within the area use for their subsistence. So, but the most hard hit is the most populous state within the region, with about 6 million people and had an economy of 6.8 billion annually. This is the most hardest hit area. Therefore, but let me apologize. In the course of this presentation, you will see some pictures that may not be very pleasant. Please excuse me, because I need to present to the world the graphic situation that is there in Nigeria, within the North Central region. So in Benue State alone, you have 726 attacks in one year from up to date. And then 60% of these attacks are women because they are more vulnerable. When attacks come, the strong men, they run away, but 60% of women are there internally displaced, killed or injured. And you know, the poverty rate now goes to 42%. Because their main subsistence is agriculture. You see, and that being the hub of agri-production, the whole country, the North Central feeds the whole country. Now, because of this crisis, man-made crisis, I have listened to the presentations before, is virus and bacteria infested crisis. Ours is man-made crisis, which are worse than the bacteria affecting agricultural production. These people now has affected, and the overall food situation in Nigeria is precarious. Food import is like 1 billion naira a day. Source is there. Import is 5 times higher than export. So you can see the problem. The population is growing at 3.2 by food.
In our program, we encourage our students, and it's a requirement that they do an internship, and also they do what we call a senior research project. And this is an example of a senior research project that I collaborated with my students on. that deals with biological function of the GAF tree assessment metabolites. So just let me give you I'll try to maneuver, instead of using the poster, I'm gonna try to maneuver the poster here on the screen. So it will be a little bit difficult, but just bear with me. So let me give you a little bit of background about the GAF tree. This belongs to it thrives globally in different parts around the world. For example, in semi-arid regions like Africa, South America, South Asia, and the Middle East. It can withstand harsh climate conditions and high salinity environments. Now, the GAF tree for the United Arab Emirates is very important because it is one of the most drought-tolerant trees in the UAE, and it plays a significant role in the UAE heritage and was declared as the UAE national tree in 2008. And also it was selected as the major slogan component of the Year of Tolerance in 2019. So it's a very, very important tree. And also it has cultural factors in terms of, for example, it could be used for medicinal properties, and it also has other important factors like environmental roles, such as enhancing the soil fertility, stabilizing sand dunes, and increasing biodiversity. In addition to other economic roles, like for example, it is used for food, fodder, and fuel source, and also used in construction and coal production. In addition to that, it has medicinal roles like being an antioxidant, antifungal, antibacterial, anti-inflammatory, and other functions. So it really captured the interest of the students and my interest to be able to look at this tree and see what else we can look at it. Now, in the literature, there are lots of research that deals with metabolites of these trees, but not in the UAE. There is not a lot of research that has been done on it. So we decided as a group that we really like to look at the different parts of the GAF tree, starting from the seed all the way to the leaves. Unfortunately, we wanted to look also at the flowers, but the flowers weren't blooming at that time, so we weren't able to do that. So what we did was we decided to take from one of the GAF trees that are around the UAE, where we took samples from the leaves, the stems, the bark, the trunk, and the roots. So we took different parts, as well as we took the seeds, but we took it from a specific organization that exists in the UAE that works with collecting of these seeds. And then what we did is right away after the different parts of the tree were collected, we right away worked on them because it's very important that you work on them fresh. So what we did is, for some of the trees, we removed the dust, and some of them we wash them to wash off the debris, and then we cut them into smaller pieces, and then we store them in the freezer in order to make sure that they are maintained, unless we worked on them right away. Now, preparation of the different parts of the tree involved steam distillation, which was used to extract the oils, the metabolites itself, and then to isolate them, we use chloroform in order to isolate the metabolites from the different parts. And then we use rotary evaporator in order to concentrate the samples to be able to have more concentration to be able to detect later on using the GCMS spectrometer. Now, the idea here was what we wanted to do is we want to identify these metabolites in order to be able to reflect on whether we can, for example, identify chemicals that could be used, for example, for understanding about the biological function of the tree, as well as to look at certain metabolites that could be used, for example, in the pharmaceutical industry to help us, for example, produce other types of medicines.
I have here a poster, a very short presentation about the importance of reintroduction of Pinus sembra in the upper altitudinal limit of the Carpathians. The title is Phenotypic Variability and Climatic Resilience of Pinus sembra in Provenance Trial of Romanian Carpathians. In 1995-1997, 6 common garden experiments were established in Romania. 2 of them was full SIB, 2 half SIB, and 2 of provenances. So sweet stone pine could be a viable solution for afforestation in the upper altitudinal limit of the forest due to its adaptability to the limited climatic condition. This species could be mixed with Norway spruce to replace the spruce monoculture strongly affected by windfall and snowbreak. The aim of this study was to analyze the phenotypic variability, trait and juvenile adult correlation in two provenance trials established in Romanian Carpathians. What you can see here, 12 European provenances of Pinus sembra were established in two common garden experiments of the Carpathian, one in Southern Carpathian and one in Eastern Carpathian. This is the map of Romania. We have a provenance from France here, 3 provenances from Austria, 1 from Switzerland, and the other 7 provenances were from Romanian Carpathians from eastern and southern part of the Carpathians. The provenances were established in 1997. In 2024, phenotypic traits were measured. We talk about DBH, breast height diameter, tree height, branches characteristics like branches diameter, branches fineness, the stem characteristics, and the survival rate was also determined.
And also we have promoting best practices in sustainable agriculture, and this also can be achieved or done through a technology transfer program to our farmers as well as to young researchers and students. Also promoting innovation and adoption of modern technologies, and this by adoption of technology program, and we have a very good relation with entities in national and international levels, and also building an efficient and effective institutions and establishing a stable and diverse funding base, and this we can done through a capacity building program. So back to my main body of the presentation. The presentation are contents are, we have introductions, challenges, that mean problem statement of the research, justification and objective of this research, and methodology, the methods that has been used during this research. So also we have a result and discussion, conclusion, and future work. So Bida, as you know, this is native to Central Asia, particularly in Iran. But widely, this plant, distributed widely. This is reflect its adaptability to wide range of climate condition. And as you know, also pomegranate is among the oldest and most significant cultivated crops. The pomegranate is growing in tropical and subtropical conditions. So we have in Saudi Arabia, we have a cultivar like a Bida cultivar. This is indigenous, we can say this is indigenous to Saudi Arabia. So here, Bida, I think it has a unique sweet taste and high productivity yields. Based on the DNA barcodes, Bida pomegranate is unique cultivar genetically, or might be adapted to Bida location. When I say Bida is area in Saudi, in south part of Saudi Arabia. So the research problem, or statement of this, as you know, pomegranate plant is propagated by rooting of hardwood cuttings. However, establishment of new plant in such condition like Saudi Arabia, it takes about 1 year or more. Therefore, the alternative method for accelerating or to accelerate the production of pomegranate clone is really needed for germplasm and conservation, as well as getting mass production for other uses. So in this case, in vitro propagation can be a solution and can offer the solution. However, phenolic oxidation is a main challenge when we introduce plant to plant tissue culture techniques. So the objective of this study developing an efficient protocol for the pomegranate propagations, identification and estimation of bioactive compound of the
only about integrated IE technology, the other services that we can consume via internet, but in the context of war and Russian aggression, it means that it helps us to survive. So, what I would like to talk for today. So, as you understand, the first and the most global issue is demining. Because according to the accounting chamber, for August 26, 2025, the potentially mined territory of Ukraine covers about 13.9 million ha. Most of them, it's agriculture land plots. So today we talk a lot about beneficial elements, harmful elements, about droughts for soil and land plots, but for us we have a big problem, pollution. And demining is the first objective that it's our challenge, that we united not only agriculture producers but also our government, and we move forward here together. And when we talk the last updates for the agriculture sector on the 2024 budget program, identified like 5,020,000 ha requiring demining. So we have some perspective, but in reality, it's also we have some bureaucratical, not like here in Europe, but also we have some bureaucratical issues, and very often the farmers are faced to demining by themselves because it's like you know it's their business. They have to do the agriculture work properly because of weather, because of season, and you couldn't postpone or don't put the rockets right now because we have to do something. No, they have to do, and unfortunately some of farmers died because they do it by themselves. So it was a huge problem, and the couple of days we had a big conference in Kyiv, Ukraine, where I moderate some section, and we have like a new program, and we hope that it will allow to do demining more fastly and more effectively. And for us, important not only demining, but fixed that such territories, such land plots were polluted, and were polluted because of aggression, because of war, because of Russia, because it's reality, it's fact. So how IE already is a part of such solution. We have like a very important, it's like regarding, we can identify because of drones, we use drones, and because of, you can see, it's like good one drones, because in the night we have bad one who want to kill us. Also, it's reality. And they, Safe Pro Group Spotlight IE has analyzed over 1 million drone images. And for instance, it's detecting 23,000 explosive hazards across 5,000 and something ha. So it's because of IE we can identify, and after we can understand how we can work with that. Also, we have the Halo Trust with AFHWC is deploying IE ML to accelerate landmine clearance.
Akmalat region using the example of the Kazger Forum. Our research was conducted in the Akmalat region in Naxos, Kazakhstan. Kazakhstan is among the countries prone to the natural hydrological phenomena such as spring floods and flash floods. The largest natural disaster in the last 80 years was the 2024 flood, which inundated almost 50% of the territories of the country's territory. Spring floods and flash floods in Kazakhstan caused by climate change, disruption of river channels, poor agricultural land and settlement planning that ignores natural topography and river slopes, urbanization of lower reach and floodplains and deforestation. Annual spring floods in the country increase water erosion, reduce soil fertility and lead to the inevitable use of chemical in agriculture. For research, you used next equipment as drone, quadcopter, global navigation satellite system equipment, kit GeoMax, forest taxation equipment, electronic measuring for EMD2 Harlow, altimeter suit, laser drench finder, agrochemical soil analysis, chemical analysis of drainage meltwater, national mandatory standard, and mobile application or MonkeyZ. We conducted research at the Kazgir Limited Liability Partnership. The plant growing company Kazgir was established in 1997. The farmland is located in the Donskoy and Krasnoflodsky rural district in the Birzhansal region in the northeastern part of the Akmala region. The climate of the region in Charlie continental and humidity in the region is quite high. The total land areas of Kazgir is more 50,000 hectares, of which agricultural land is more 50,000 hectares, arable land more 25 hectares, and pasture more 24 hectares. The total area of crops for 2024 was more 11,000 hectares. The average yield was 32 cents for 1 hectare.
For animal feeding, and you produce it for human consumption. In that case, we focus our research in having a technology that allows us to get the bromatological of the moringa always the same, and to obtain a moringa leaf, a safe leaf, free of contaminants from the soil. So we decide a frame that gave more fill, and then on here you can see the process manufacturing of the moringa. Here is the harvest of moringa in this place that, as you can see, is mainly manually. The person use glove for collecting the moringa leaf and put in a plastic bag the moringa leaf after collecting, and it is moving to the factory in a closed car, and at the factory also people are wearing all the necessary clothes, and after is the steaming and washing of the leaves, centrifugation from removing water, and after drying on a solar oven, and after milling in the case of producing power. You see, about all the results about our study, we publish in different papers. If you are interested, you can find them in those publications. We identify that no was any international standard for producing moringa on this way, so we presented and were approved in Cuba the standard for producing the forest code of hygiene practice for natural product based on moringa oleifera for human consumption. And after, the second, this was in 2020, a second we obtained in 2022, that is presented all the specification, quality specification of the moringa. It, of course, include a big base data of bromatological parameter of moringa different lots, yeah, during 2-3 years. So in our moringa we identify as the a more important compound active that was quercetin, about 2% of quercetin in leaf we had, and all our study you can see, or you can find in those manuscripts that we publish in several journals. And we study also different or several effects, biological effects in preclinical studies. In this case, we identify the hypolipidemic effect of moringa dry. No? This study was made in male Swiss albino mice. It was shown that the treatment of moringa had a better effect on the cholesterol and not on triglyceride. No? And also we saw that the continued treatment with double amount of use of moringa show a better response in reducing the low density cholesterol and increasing the high density one. It's a good result that satisfies us. Also, we found anti-diabetic property of moringa leaf that the 45% on ethanol extract show set inhibitory activity of alpha-glucosidase enzyme in vitro studies. Also, antimicrobial.